Alright, gang, we may get through the rest of the chapter today. Seeing as how I believe it's only over the sort of logic that I bet we already know from our fundamentals class. So we've talked about if. We know what if else does, and we know what if else if does, right? In fact, we had a project over that, right, where we figured out what the density was based on their choice. So we have the logical operator, and two ampersands make up and you use them to check to see if two conditions are true. Now this is deceptive because this is not valid code. They say it's pseudocode, but it's not valid code, and if you typed it in, it would fail. Why? Because temperature greater than 50 and less than 90. It'd be great if we could type that syntax in, but here's what it really has to be to work. If temperature greater than or equal to 50 and temperature less than or equal to 90. Why? And is a Boolean operator. It requires two pieces of data on either side to work. But we've got two pieces of data. No, we don't, because this is going to evaluate to true or false, right? And say that evaluates to false. And so now we've got if false and less than 90. Well, what is less than 90? The compiler has no idea, right? So you can't do that. On either side of the and keyword has to be a complete valid expression, such as if temp, is greater than or equal to 100, or whatever that value was that they liked, right? There, 90. Temperature greater, less than or equal to 90. Notice that and is used to check to see within a range, right? If it's greater than or equal to 50 and temperature is less than or equal to 90, it's in that okay range, so we can print okay. And is used to check within ranges, among other things. Or is used to check outside of ranges. If we wanted it to print not okay, and we wanted to check outside this range, or, the freezing and boiling point of water, which is 32 and, 212. If, temperature is less than or equal to 32, or that's shift not shift to the backslash, bar. At a certain point, I'm just going to say or, right? I'm not going to say bar. That sounds silly. Or pipes, or whatever the other terms are for that. Vertical lines, temp greater than or equal to 212, then we could print not liquid, right? Because in fact it's not. So we have used and up here to check within. Use and to check in range. Use or to check outside of a range. So here we go. As I mentioned, both sides of the and symbol have to be complete expressions. So that's what they did here. Temperature greater than or equal to 50, that's a complete expression. Temperature less than or equal to 90, that's an expression. And then they chained those two together with and, meaning that both sides have to be true before the result is true. To check to see if something is outside of a range, you use or. If temperature is less than or equal to 32, or the temperature is greater than or equal to 212, right? Only one side has to be true, right? They don't both have to be true. If they're both true, so much the better. But if it's less than or equal to 32, it's not a liquid. Or if it's greater than or equal to 212, it's not a liquid. The program on the next slide determines whether the fans at a baseball game win free French fries. If the home team wins and the score is at least 100 points, the program prints this message: fans, redeem this ticket stub for a free order of French fries at Yummy Burgers. On the next slide, replace insert code with the appropriate. So what are we doing here? What does our code look like? We ask them for the number of points earned by our team. We ask them for the number of points scored by the opponents. And then the home points. Opposing team. All right. So then we have to calculate what we are going to print. So how do we know if we won? If the home points is greater than the opponent's points, right? But that's not good enough, right? Because we also have to see if we got 100 or more points. So if home points greater than opponent points and ampersand, home points is greater than 100, then print free fries. System.out.print free fries, right? There we go. That's the logic for doing that. Yes, you could do a nested if as well. You could do this. If the home points is greater than the opponent points, then you could have if home points is greater than 100, right? If you even felt like it, you could put in all the braces necessary. That's true. Quite often, nested ifs can be expressed with an and. Or you could say that and logic could be expressed with nested ifs. Either way, right? If you are sick and you are tired, you can stay home. Nah, I don't like that example because I'd rather say sick or tired. How's about we say if we have money and we are hungry, right? So if money greater than 5, costs more than $5 to go out to eat, and if hunger, our hunger level is greater than 20%, we're greater than, you know, 1/5 of our hunger, then go out to eat. Standard.o, right? System.out.println, go out to eat. Sure, you could do it with nested ifs. Or you could just chain them together with ands. If the money is greater than 5 and our hunger, I'm sorry, that should have been a greater than sign, right? Greater than or equal to. They both could have been greater than or equal to. So if money is greater than or equal to 5 and our hunger is greater than or equal to 20%, because we're playing The Sims or something where we can track our hunger, then, you know, system.out.println, go out to eat. And I wish Java would accept like SOP. I wish NetBeans would accept SOP as an abbreviation for print, and it would pad it out with all the text. You would probably write some macro inside NetBeans and have it do that, right? But we see here that and can be the same as nested ifs, or can be the same as if else's. Not always, right? But sometimes, right? So if sickness is greater than 0, even if we're a little bit sick, we're going to stay home, right? And let's do that if it's a weekend or if we're sick, right? So sick is equal to true. Weekend is equal to false, right? So we could say if weekend, print sleep in late, right? Else we could say else if sick, print sleep in. So we get to sleep in, and you know that it would really need to be system.out.print, right? So there we go, right? And I don't know why I put I'm botching this completely. There we go, right? So that's pretty much valid code, except these variables are not defined. They would need to be defined as Boolean variables. So anyways, we could rewrite this to say if weekend or sick, right? If weekend or sick, then print sleep in. Look like I forgot a letter up here, right? So chained ifs, if, else, if, as long as the result is the same, can be combined into a single statement with the or. Now if the results are different, right? Else if tired, print sleep in just a few minutes, right? Now the results are different, right? Sometimes we get to sleep in till noon, all right? Or whatever. We just get to sleep in a lot, but if we're tired, we get to sleep in a little bit. We could not duplicate this logic with a single or, right? Because there's several different results. But if they're the same result, you can use or to replace if, else, if. Provide code that prints by if a response variable is a lowercase or an uppercase q. If response.equals lowercase q or response.equals uppercase q, then print goodbye. There's plenty of other ways you could do that. You could use equals ignore case. If response.equals ignore case q, then print goodbye. That's enough. You don't even need to use an or. But that's just because we have an equals ignore case method as part of the string class. What if they type in the entire word, quit, rather than q? Well, we could do char at. If response.char at, if the character at position 0 equals a lowercase q, or if response.char at 0 is equal to uppercase q, then print goodbye, right? Sorry about that line being there. There we go. That's another way to check. That way would blow up if the string was empty. If somehow they managed to type in a string that was empty. But if you call .next to get what they type as a string, .next is not going to return an empty string. So this would be an okay way to do it. The advantage of this way is if they type in the entire word quit rather than q, then it would still trigger as valid. Of the two, I would probably go, in this particular case, with equals ignore case. And apparently I've done way too many changes to get that to work. So equals ignore with a capital I, case, parentheses, lowercase q, and lowercase. Right? Like that. But the or logic worked just fine as well. Just like that. If response.equals q or q, no, that's a bug. Can't do that. That's an error. You can do it like this, but no, you can't. You have to use equals to compare strings. You cannot use equal equal. If you've ever taken C++, you may know the idea of operator override. Well, Java does not have operator override, so we can't change the meaning of equal equal. So if we try to use that to compare Q and response, this is only true when the address of response is equal to the address of Q. And that's never going to be true. So as I mentioned, you can use the ignore case. The not logical operator. It just reverses the truthiness of it. What do I mean by that? See this, if reply is equal to lowercase q, or if the reply is equal to uppercase q, we're going to say not. So if this condition is true, if it equals q, then we're not going to get started. But if it's not true, we are going to get started. Now, if you don't like that not there, you could say while reply not equals q and reply not equals uppercase q, right? Maybe that looks clearer to you. It looks clear to me. If you think the other way was better, that's fine. What if we use that equals ignore case? We could say if not reply dot equals ignore case, to a q. Right? So if that's true, then this switches it to false. And if this condition is false, if they didn't really choose q, that's when we print let's get started. Because if we were quitting, we wouldn't get started. So you saw a minute ago how I flipped having a knot on the inside, outside, to knots on the inside. That sounds strange. But anyways, and I forget the name of the mathematician who invented the law. It's named after him. Let me pause and see if I can find it real quick. Okay, here it is. De Morgan's law says, and they phrase it a little bit differently. They're saying that plus is equal to an or, times is equal to an and a little apostrophe means not. Okay, so it's De Morgan's law. I'll take a note up here, or I could actually put it in here. Wow, I don't have anything in here so far. Well, let's do it, right? De Morgan's law, which is not X or Y, is the same thing as not X and not Y. And vice versa. Not parentheses X and Y is the same thing, or not X or not Y. I don't know why I used the word and then I forgot to use the word or, you know, here, okay. Go with the English words. Okay, so notice that the sign flips as well as not getting inserted inside the things in the parentheses. So let's say that we're checking to see if we have water at all, right? So we're going to say the temperature is, you know, -2 degrees, right? And we're going to say that the amount of water is equal to 7 grams. Why I'm not storing these in double, I don't know. So anyways, we have ice when the temperature is less than or equal to 32 degrees and we have water, right? If neither case is true, then we can say that there is no ice. So, if temperature is greater than 32 and the water is greater than 0, then that means that we have ice. So, no. There we go, right? If the temperature is greater than 32 and the water is equal to 0, in that case we have no ice. System.out.println, no ice. Well, let's rewrite that using De Morgan's law. If not, and we need to swap the sign in the middle, and we need to write the case as its opposite. And the opposite of temperature less than 32 is temperature, or excuse me, temp greater than 32, its opposite is less than or equal to 32. Or water not equal to 0, then system.out.println, no ice. Alrighty, which one's clear? To me, this one's a heck of a lot clearer than this. So, if I am not sick and I am not tired, I'm going to go play the game, right? So Boolean sick equals false, but I might be tired, right? So we're going to make another one. Boolean tired equals true. So if I am not sick and I am not tired, then I'm going to go play the game. So if not sick and not tired, system.out.println, go play the game. Right? But we can rewrite that using De Morgan's law, which means take the not, put it on the outside of a pair of parentheses, flip this to an or, and flip these to their opposites. So if not sick, that really looks weird, or, and what's the opposite of not tired? I think I'm spacing out on this. I believe that's correct. Yeah. Looking at this example confused me a little bit. So, I believe that this means the same thing as this, right? If we're not sick and we're not tired, go play the game. If we are sick or tired, but that makes it not. So if we're not, parentheses, sick or tired, in parentheses, then we can go play the game. Which one do you prefer here? I don't care which one you prefer. I'm not sure which one I prefer. I think I like this one in this case. Right, I think that's a little bit clearer than this. You can say that the more knots that you have in an expression, the more your brain gets tied up in the knots. I'm not sure of a good way to remember that, but anyways, the more negatives you have, it's like saying I am not unwilling to go, right? And you have to think of what that really means. I am not unwilling, then okay. Then those two no's make a yes, right? So that means that you are willing to go, right? But the double negative, your brain had to rephrase it. Anyways, you can use De Morgan's law to flip the logic if you have a not in front of it. Just switch the middle of it, make these things like that, and you're good to go. I really kind of wish I hadn't done this example here. But it does show that you can rewrite things, you know, in more than one way. Here we were checking, no, I'm done talking about that. Let's go on. You can use switch case to make it so-called more elegant. Elegant code is easy to understand. Switch based on your expression, and then case, do something, break. Case something else, do something else, break. And then if none of those cases are true, default, do a third thing. So how the switch statement works. Well, let's write a switch statement that calculates somebody's grade. What are we going to do? We're going to divide the grade by 10, right? And if they have 100, then it's going to be 10. If they have a 95, a 94, a 93, we're going to do integer math. So we're going to take the score and we're going to divide it, and then we're going to cast it to get an integer. So what was our score? Double score. We made an 85 this time, right? We'd ask the user really. But now we need to get the first number in the score, whether it's a 10, 9, 8, 7, 6, 5, 4, 3, 2, or 1. All right? So int, I don't know what I'm going to call this, first is equal to the cast, the int version of score divided by 10, right? So if their score was 100, it's now a 10. If it was 90, it's now a 9. And what is this doing? It's taking a double and converting it to be an int. This is what's known as casting. Cast the result to an int, because otherwise it won't compile. Not in this language. In C++, it'd go ahead and convert it to an int just because. Here we have to explicitly say, no, what we really wanted was an int. All right, now we can set up a switch statement, right? We know what the first part of the number is. So switch based on the first. So case 10 colon or case 9 colon. If either one of those is true, then we made an A. System.out.println parentheses quote A, end quote, in parentheses semicolon, and then break. Now this code is going to be pretty repetitive, so I'm just going to do some copying and pasting. I'm going to take those 3 lines and make some changes to it each time I paste it. Whoops, that wasn't a copy and paste. Here we go, right? And we need one for a B, one for a C, one for a D, and one for an F. But F is going to be instead be the default clause, because anything lower, if I could spell default, I'd be so much happier. There we go, right? Okay, So this is giving errors right now because it's telling me that this 10 and 9 have already been done. These are duplicate cases. It says duplicate case label. But a B is really an 8, right? Because you made an 80 or above. A C is really a 7, right? If you scored in the 70s, you make a C. A D is in the 60s. And if none of those things is true, then we're going to print out F and we're going to be done. So since we're done, we need our closing brace. I'm going to put a comment as to the effect of where my closing brace is because I'm getting confused. This is the end of the switch. All right. I'm going to take out the case where we can earn a D. In this particular teacher's class, all you can make is an A, B, or C, or an F. And the reason I'm doing that is just so I can try to get these lines of code on the screen, to get everything on the screen, right? So we would read the scoring with a next double, you know, sc.next double or whatever. We would divide the score by 10, turn it into an integer so that we could check to see if it was a 10 or a 9 or an 8 or a 7. And a 10 or a 9 is an A, an 8 is a B, a 7 is a C, and anything else is an F. Even if it doesn't seem like you need to handle a default case, if you think you've accounted for everything up here, nah, you really haven't. So always put a default down here. And I won't say, nah, you really haven't, but it's possible that you made a mistake. And so it's a good idea, it's good programming practice to have, if you have a switch and you have a, you know, several cases there, go ahead and throw in a default, even if all the default is going to do is print out an error message. For example, what if I just flat out forgot to add the D? Well, if I didn't have my default here, then when they entered, you know, a 60, it wouldn't print anything. They might not notice that it wasn't giving the right output. But if it's printing out that it's an F, if I put in a default case here, then hopefully when they typed in 60, they'd see, oh, that's the wrong output. Or if they couldn't make a 60, if all we were supposed to be able to do is an A, B, or C, you could make this print error, right? Error, invalid input, right? Something like that. Always a good idea to put a dangling else after a chain of if-else-ifs. It's always a good idea to put a default if it's a whole bunch, you know, if it's a switch statement. Hope that makes sense. What if you had a phone? Remember the good old days when if you had to send a text message, right? Phone, touchpad. Well, fine. Keypad. Oh, well, I saw one right down there, right? In the good old days, if you wanted to send somebody the word wow, you would have to type in a 9. Let's get this over here. A 9 for the W. And then you'd have to type in 666 to get to the O. And you'd have to type in a 9 again to get to the W. What if the message that you wanted to send was the word Fred? Well, an F is the third position, so you'd have to type in 333. Then you'd have to find the R, which is down here, and that's the third position, so you'd have to type 777. Then to get back to the E, E is in the second position, so you type in 33. So far we have 333, 777, 33, and to get to the D, one more 3 with appropriate pauses in there. And then your little flip phone would actually be able to send the message Fred. All right. How did they create these letters to associate with these numbers in the first place? Well, back in the old days, you had what were known as telephone prefixes. And the prefixes were some kind of word that would serve as a mnemonic for the first 2 letters of your phone number. So for example, where's my notepad? Midway City's prefix was RE, right? So if you had that word RE, and then the rest of it, that would be my phone number. Regent, I typed that below where you can see it. Regent 74988 might be my phone number. And the way that I would translate that is, what is an R? Well, an R is a 7. What is an E? An E is a 3. And then my phone number would be 737-4978. Right? Just like that. And there were different prefixes for all sorts of different numbers, right? What if your number was 62? Well, you'd have to come up with some word that began with one of these letters and then one of these letters. Like, I don't know, M and 6, right? So you could have the letter M to represent that, and you could have the letter A to represent that. So MA, and then you need to come up with some rest of word. Magenta, 30203, right? And the way that would be translated into the first two letters, well, what's an M? An M is a 6, and a 3 is, an A is a 2, right? So that's 62, and then the rest of the phone number would be 30203. So say we didn't have this touchpad in front of us, and we wanted to be able to type in a letter, like an M or an A, and have our program tell us whether it was a 6 or a 7 or whatever. You could do those with if statements. You could do those with case statements. So we could do this, right? We could ask for the letter. String letter is equal to sc.next. Right, like that. And then we could check, right? If letter dot equals an uppercase A, or if the letter dot equals a lowercase a, you can probably see where this is going, or if the letter dot equals an uppercase B. Why don't we just use equals ignore case instead? Shorten this just a little bit. So if the letter equals ignore case A, or the letter ignores equals ignore case B. I'm going to print that out again. Or the letter equals ignore case C, then we know that it is a 2. System.out.println parentheses 2. Like that. Maybe we'd put braces there to make it look easy to read. We're going to need a closing brace there. There we go, right? That would check to see if it was an A, B, or C. And if it was a D, E, or an F, then that would be a 3, right? So you could tack on an else. Else if D, E, or F, print out that it was a 3. See, that's one way you could do it. You could also use switch, right? You could switch based on the letter. Switch based on the letter. And case A, colon, case B, colon, case C, colon, but we're also going to need the lowercase versions because there's no case insensitive, there's no ignore case version of switch. If it's an A, B, or C, or if it's a lower A, B, or C, then we would print out 2. Then we would need to break. We would need to do the same thing to handle the 3s, right? So if it's a D, if it's an E, or if it's an F, and then the lowercase versions are the same, somewhere I forgot a quote. All right, there we go. And then it's a 3, and so on. We would probably want a default case to say unrecognized letter, right? System.out.println parentheses quote unrecognized letter, something like that, right? And just great. I've been typing all this with it right off the edge of the screen, even though I was reading it aloud. Apologize for that, gang. Need to just move Notepad over there. Hopefully you could tell where I was going with that, even if you couldn't see last columns. All right, so we have 2 different ways of handling this, right? If the letter's an A, B or C, print 2, else if the letter is a D, E, or F, see I'm using ors, then print out 3, or so on, right? Our final case could be, you know, else system.out.println unrecognized letter. Like that, or you can do the same thing with switch case. Which way looks easier to you? That's your choice. Are there other ways of doing this? Yeah, you can probably come up with some other way of doing this. But that's going to be your homework assignment. Your homework assignment is going to be to take a letter. Well, where'd that come from? Take a letter and turn it into turn it into a digit based on the telephone prefix rules. Let's go up here and look at Oklahoma telephone prefix, just out of curiosity. Oklahoma telephone prefixes. Oklahoma letter prefixes, or word prefixes. So they call them officially telephone exchange names, it looks like. So for Oklahoma, Midwest City, 7-3. Regent was one thing, but if you lived in another part of the country with a 7-3, they may have called it Pershing. If you lived somewhere else, they could have called it Republic. Somewhere else, they could have called it Redwood. All right. Isn't another zip code or prefix 848, like 84 something in Oklahoma City? I don't know all the Oklahoma City prefixes, and I'm sure that they've added some, but they might have called it, you know, Thornwell, Tilde, Victoria, Viking. So as long as the first 2 letters were 8 and 4, that's what it would mean. All right, I'm not spotting a cool list of what they used to be. All right, so old Oklahoma City phone numbers. Jackson, 5-2. Parkview, 7-2. Sunset, 7-8. Skyline, 7-5. Swift, 7-9. Greenfield, 4-7. Pershing, 7-3. Now I know it's Regent because my grandparents had a telephone where their phone number was actually printed on it as Regent 3-1234 or whatever. And then so Stillwater had their own set, right? Here's a pretty long list. See, Regent, that's what I'm saying. And so your phone number might have been Trinity 5-1234. All right, so that's enough background of that. That's just trivia. So if you grew up in the 40s, 50s, 60s, or whatever, then about the 70s, they changed over to being purely numbers, right? Didn't need to remember a word anyways. They figured out that, you know, our brains could actually hold a 7-digit phone number. All right, that's about enough. So that's going to be our homework. I'll write it up nice and pretty. And let's go back and see how much farther we need to go. We've talked about the switch statement a couple of times. I don't think we need to mention it anymore. Their example is zip codes. If your zip code begins with a certain number, where do you live? Well, our zip codes begin with a 7, so according to them, we live in the south. While loops. We're changing directions entirely. So we may actually stop here. Well, this lecture's only been 40 minutes long. We could go a little bit more. And you know what a while loop is anyways. So while condition, do some block of code. Do a block of statements. That's the pseudocode syntax. In Java, you actually have to use parentheses around the condition, unlike Python. Write a main method that finds the sum of user inner numbers where -9999 is a sentinel value. So here we go. Sum of user inner values is 0, and then we have a loop. We ask them for the number, and if that number is not equal to that, we add it to the sum. We could write something like that, except let's just do test scores and not equal to 0. Let's go ahead and create our scanner. I'm going to have to add the import for it. Scanner SC is equal to scanner parentheses system.in in parentheses semicolon. We need some values, right? We need a total, double total, equals 0, and we're going to need a variable for the score. Well, we can just, let's go ahead and add that import right now. Create class scanner, create class, okay. See, that would be a terrible mistake to do, is to create a class scanner. Instead, I want to have the Java util scanner version. So I don't know why I did that. So up here, I'm just going to add import java.util.asterisk semicolon. Is that going to fix that? Alright, I'm completely boggled. Simplest thing in Java, and my scanner isn't working. Alright, the only problem was that I hadn't saved it or compiled it. So once I saved it and then compiled it, it worked just fine. And if I had not had my import up here, then saving it and compiling it would have allowed me to click on this and add the import. Still, it would have been terribly wrong for me to choose create class. Never, ever, ever click on create class to fix a programming error unless you're absolutely sure that's what you're trying to do. And for a scanner, no, we're not trying to create a class. We just need to add the import. Okay, I said we need to add the import. Let's get our first score. System.out.print, enter test score, or -1 to quit. And we already done this. End quote, in parentheses, semicolon. And let's read it in. Total equals sc.next double, with a capital D. Parentheses in parentheses. Now we have a test score. While, no wait, that's not supposed to be the total. We're supposed to be asking it for the score, right? So double score. Why don't I just create score as a variable up here, double score. And so score is equal to sc.next double. While that score is greater than or equal to 0, right, as long as it's not negative, or while it's not equal to -1, that we made that our sentinel value, not equal to -1, then we're going to add that to our total, and we're going to ask again. Total plus equals score. Add our score to a total. Now what? Oh, that is correct. I already did have a variable up here called score, way up there. So I'm going to call it test score. Test score equals sc.next double. While test score not equal -1, total plus equals test score. Then we have to ask for our input a second time. So I'm just going to copy those two statements and paste them at the bottom of my while loop above the closing brace. There we go. Right? And then we could calculate our average really nicely if we had a count of how many test scores have been entered. So let's add a count, right? Count is equal to 0. That's how many test scores have been entered. As soon as they enter a valid 1, no, we're going to increase the count by 1. So count plus plus. Then down here at the bottom, we could calculate our average. Double average is equal to the test underscore divided by the count. And then we could print the result. System.out.printf, parentheses, quote, average score equals %.2f, backslash n, end quote, comma, average. Now this has a bug, actually. What's the bug? Well, let's run it and make sure it works correctly. Enter test score. Okay, I made 100, then I made a 90, I made a 95, and the average should be 95 when I quit. So -1, the average score is 0.33. Well, where did that come from? Because in order to figure out what's wrong, I'm going to set a breakpoint on this line so that it runs in here, it lets me type in something, it adds it to the test score, and then the program will stop there. All right, and so then I'm going to do run debug project, debug project. I need to enter the output that it's asking for. Where's my output window? Right here. Enter a test score. I earned 100. So what is my total at this point? My total is 100. What is my counter at this point? 1. That looks good. So I'm going to let my program keep running. I'm going to press the green circle here. It's going to ask me for another test score. 90. All right. So at that point, it is looped around. Our test score is equal to 90, and our total is 190, and our counter is 2. So I'm going to type in -1, and then I'm just going to skip line by line. It's going to exit the loop because the test score is equal to -1. So step over, it tests it again, it exits the loop. Our test score, where did test score is equal to -1 come from? Oh, because the average is not the test score divided by count. That's idiotic. Press this red stop box. The average is equal to the total divided by the count. Okay, but you saw me use the debugger, and it's really incredibly important to know how to use the debugger. I encourage you to use it on your own projects when you're trying to figure it out. Okay, so we demonstrated using a sentinel value and a while loop, and as long as this loop was good, then it kept going. When test score was finally equal to -1, we stopped. I'm going to show you an alternate that the textbook does not show you, which is to use a break statement to exit the loop. And I'm going to use what's known as a while true loop. By the way, this is the end of main. This is the end of class. Just putting those there to make sure that I don't make a mistake. Okay, so I'm going to do the same thing here. Total is equal to 0. Test score is equal to 0. Not even really necessary to have that because we're going to be reading it in a minute. But while true, in other words, repeat forever. This is an infinite loop. But there's going to be a break statement that kicks it out. So let's ask for the score. To cheat, I'm just going to copy these two statements. The print and the test score equals next double. They seem to be good enough before. They ought to be good enough now. Now we're going to check. If the test score is equal to -1, we're going to break. If test underscore equals -1, in parentheses, break, right? Because they typed in a -1, they're done. But if they didn't do that, else, curly brace, we're going to add what they typed to the total, and we're going to add 1 to the counter, right? So, add 1 to the counter, count plus plus, and total underscore score plus equals test score. And it wasn't called total underscore score. Maybe I should have called it that. I'd be better at memorizing it. All right. Now, do you even strictly need this else? No, because if the break statement doesn't kick us out, it has no alternative but to do the rest of the code. So I can get rid of that else. If you like the way the else looks, you can leave it there. Okay, so this is the same way of writing a while loop, or I should say the same functionality. You have a while loop, you have a sentinel value. It's just a while true with a break when they finally type in the sentinel value. This is my preferred way of doing it. Why is that? Because our input only occurs in one place in the logic, whereas if you do this, we had to have the priming read, so we had to have the input above the beginning of the while loop, and that was repeated here. And so you had to do it 2 places there. Here you only had to do it 1 place. That's my preferred way of doing it. Whichever one you prefer, it's up to you. To me, my brain works like this. Keep doing this forever until then, and when this until then is true, break. There are other kinds of loops. There's a do loop. A do loop has the condition at the bottom rather than the top. Do this chunk of code while this condition. So that could be something like this. And maybe we'll make this, I forgot that loops were in this chapter, so it's taking us a little bit far longer to get through it than I expected. We're going to save the rest of it for next lecture. But anyways, let's do this. Int x equals 0. While x is less than or equal to 10, system.out.println x, right? And so it's going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe we'll start it at 1, right? But we need to increase x each time, or else it's going to be an infinite loop, and it's just going to print 1 endlessly. And so I'm going to add 1 to x there. The while loops are known as pretest loops. Pretest because the test happens above the body of the loop. But you can also have do loops. X equals 1, do this business of printing it out and adding 1 to the counter, to the loop control variable, the x. And keep doing that while x is less than or equal to 10. I'm expecting it to print out 1 through 10 and then 1 to 10 again. Let's see if that's the same output I get. Enter your test score, -1 to quit. Oh, by the way, I said I had a bug up there. If I just type in -1 so they have no test scores, it says that the average score is NaN, which stands for not a number. Why? Because we added our total, we divided our total, which is 0, by the counter, which is also 0. And whenever you divide by 0, it's a problem. It could have even crashed the program if these had been integers, but if you divide a double by 0, it assigns a specific value called NaN, not a number to it. Anyways, so I should have some code up there when I'm going to print out the average that says if the count is 0, then handle it in some different way. But I didn't. Okay, so the first time it counted 1 through 10. The second time it counted 1 through 10. Did the same thing, right? Well, they're the exact same loop. Not really. They're not the exact same loop. But I am going to say that this is a post-test loop. And it's important whether it's a pre-test loop or a post-test loop, because what would happen? Let's add something to our print statement to show that we are in the pre-test as opposed to the post-test. So this print statement is going to be pretest colon end quote plus x. This print's going to be post-test colon end quote plus x, right? That way when we run it, we'll be able to tell the difference between the two loops. -1, -1. All right, got, see? Pretest 1 through 10, post-test 1 through 10. Great. Work the same way. But what if x was set to 100 for whatever reason, and then we reset it to 100 here? Well, while x is less than or equal to 10. Is x less than or equal to 10 at all? No, it's not. So it's going to skip the entire body. We're not going to see the word pretest printed even once. But when we get down here to x is equal to 100, all it says is do. There's no condition here to stop it. So it goes ahead and prints out post-text and x and adds 1 to x, and then it checks. Well, you know, by then x equals 101 because we added 1 to it. Is 101 less than x or less than 10? No, it is not, so it'll exit the loop. So we're not going to see any pretest output at all, and we're going to see one piece of post-test output. Now let me enter my -1 again, just to get it past the reads. All right, you see that? It didn't print pretest at all. Instead, it did print one post-test. A pretest loop, the body doesn't even get executed if the condition is false. A post-test loop, the body always gets executed at least once, even if the condition is false. That's worth writing down as a note. Pretest loop, the body doesn't get executed even once if the condition is false the first time. Post-test loop, the body executes at least once, no matter what, no matter if the condition is true or false, right? Because the evaluation happens after the body. That's why it's called post-test. All right, hope that makes sense. Then there's one more loop called a for loop, and it's actually got two different syntaxes. So we kind of have two more loops coming up, the for loop. You know while loops from your prior programming classes. If you've never taken a C or C-based language, then you probably have not seen a while loop. And now you have. It's just that Python didn't have it. Alrighty, I will write up the homework being the touch key assignment, and we're done for today.